Hello, I'm Casey Chua. I'm the MC for today's event. A very good afternoon to our industrial judges, esteemed industrial partners, ladies and gentlemen. Welcome to Singapore Polytechnic Engineering Show Webinar 2021, the first digital SP engineering show with virtual project showcases and demonstrations put together by the SP Engineering Show Committee. In this webinar, you will be presented with a wide range of innovative industry projects, which are the hard work of our final year's students. These student-led innovation and industry-ready projects are specially developed and curated based on real industrial problem statements through the use of creative engineering efforts. So stay tuned to find out more about the different project domains, which covers advanced manufacturing, 5G, artificial intelligence of things, in short, AIoT, augmented reality and virtual reality, robotics, autonomous vehicles, and green environment. Without further ado, first of all, I would like to start by introducing the panel of project judges consisting of experienced and senior members from the industry. In alphabetical orders, we have Mr. Bobby Lim, co-founder and chief builder officer from Circular Blueprint.
Hello, everyone.
Mr. Lim.
Hi.
Mr. Han Ni-Juan, general managers from Yokogawa Engineering Asia Private Limited. Mr.
Hi.
Han.
Good afternoon.
Hi. Good afternoon to you too. Mr. Law Chun Min, senior VP, Innovations and Transformation from NSL Limited. Mr. Law.
Hi, good afternoon, everyone. This is Chung Ming.
Good afternoon to you too. Mr. Leonidas Dipari, Head of Hardware Engineering from Continental Automotive Singapore Private Limited. Mr. Leonidas.
Yep. Hello. Hi.
Hello.
Yep.
And finally, sure, I can hear you very well. Thank you. And finally, Mr. Rico Cruz, Training Managers, Maritime Human Resources from NYK Ship Management Private Limited. Mr. Rico.
Good afternoon, everyone.
Good afternoon. To all judges, a sincere appreciation for your time. Thank you. Now let me start off the project showcase segment for today's program. There are altogether 5 projects that will be shown to you. The presentation will start off with a project introduction video, followed by a Q&A session where the judges will ask the teams about their projects. The first project lined up for you is titled Video Analytic-Based Smart Facilities. The student presenters is D'Souza Virgil Sanjeev. Over to you for the video presentation.
There's this COVID situation going on, so what we're trying to do is to minimize human contact to prevent the virus from spreading. So we came up with this contactless method by using a video analytics-based camera with built-in artificial intelligence to manage these facilities. We are trying to simulate a museum environment. So the customers will purchase the tickets and submit their picture for on-site verification. So when they arrive at the museum, there will be a video analytics-based camera deployed at the entrance to verify its identity. There will be many cameras deployed in the museum to monitor areas of interest, such as restricted areas or manless information counters. So when the customers need help, they can approach the manless information counter and wave their hand to notify the staff. So the staff will receive notification alert. Then they can approach the customers for assistance. When the customers enters a restricted area, the camera can detect and alert the security guard. It can also analyze the visitors' movement, so they can track visitor pattern. For example, how many visitors are coming in and out of the museum. As we are in an aircon environment, there tends to be fogging around the camera, which makes it hard to detect objects. I applied an anti-fogging marker on the lens to prevent the fogging. In order for the collected data to be displayed on a dashboard, I needed to write a piece of software to extract the metadata. So this part needed a lot of in-depth knowledge of networking and protocol, which took me a lot of time to master. So through this project, I've understood how the whole system of video analytics works. I see that there is a trend for video analytics to become a generic sensor. In the future, I hope to see more of these technologies used in other areas and facilities.
Now I would like to invite the panel of judges to pose their questions to the project team. May we start with Mr. Bobby Lim, please?
Hi. So sorry, can everyone hear me?
Yes.
Okay. So that was a really great project. I really like it, and I do believe that video analytics sensor can also become a generic sensor in the future. So one question I have for the team is, moving forward, what are the challenges that you foresee up ahead?
Well, I think the first and foremost challenge would be the cost of the cameras, because one of the Bosch cameras costs maybe like thousands of dollars even. Because it's a very, very technologically advanced camera, because it can do video analytics, which is of course very, very complex. So one of the main challenges that we face right now is the cost of the project. Yeah, because while this technology is still currently under development, in the foreseeable future, we will see more and more of these types of analytics in demand, and hopefully, deploy it to other usages. So overall, the cost of this project is estimated to be $2,000, which can be quite pricey at the moment.
Do you have another challenge?
Yeah, I would think also some of the hardware as well, but we have a proper documentation of the hardware. So all I had to do was just to read up on the documentation and see which parts are most relevant in the context of our project.
Thank you, Mr. Lim. Could we have Mr. Han to ask the next question, please?
Hi, good afternoon. I think I like your project, but I wanted to have a question is that why is your project unique or innovative compared to what is already available in the market?
Okay, first of all, this system is intended to be contactless, which is of course very relevant, especially since now we have the COVID-19 pandemic, where we try to reduce as much contact with one another as possible so as not to transmit the virus. Because we try to also use video analytics in this context, and also the facial recognition technology is quite useful, because the user kind of registers his face with the museum, so that the museum can kind of verify the information before letting him in. And in the context of the counter monitoring as well, we also plan to reduce manpower in patrolling restricted areas, or having someone like at an information counter to kind of answer the visitors' queries. Yeah, so this is very useful, as it can reduce the manpower needed to patrol the museum and also to ask for assistance, because one staff can just be somewhere else, and then when the user raises his hand to ask for assistance, then the staff can just come out. So there's no need for anyone to be there the whole day.
Thank you.
Right.
Mr. Law,
All right, thank you.
Questions? Mr. Law, please. Mr. Law,
Sorry,
we
what
have the
sort
next
of
question,
what
please.
sort of features will you add on in future versions of this solution?
I think definitely would add a buzzer to this, to kind of alert a visitor in case he enters a restricted area, or like he's loitering around, spending too much time in certain areas, to kind of remind him to move away from the area. And also plan to have facial detection with mask on, and so that the video analytics software can recognize whether or not the user has a mask on and alert them to to ensure that they keep their mask on, and also hopefully we can have a algorithm to track whether or not the visitors are abiding by safe distancing measures which are currently in place, and also we plan to have a permanent display near the facial recognition camera which lets visitors into the museum.
Okay.
Okay.
Yep.
Mr. Leonardus? Yes, could we have a question?
Yes. Yeah, my question is that the team, the project team, are you guys working mostly on the software itself? Because it seems to me more about the software algorithm to make the detection. But are you guys also working on the hardware? I mean, like camera hardware. So I just want to know whether you include the hardware system or only the software part of it.
I would think that it is mostly on the software aspects of the camera, but I think in terms of hardware, all I have to do is just where to deploy the camera, and also to kind of have for the camera we have the adjustment of the angles. Overall, I think this project would focus more heavily on the software aspects, like for example the metadata publication, to allow the camera to analyze the grounds through the video. So it's all I would say is mostly software based.
Okay, understood.
Thank you. And Mr. Rico, we have the next question, please.
Yeah, good afternoon. So,
Good afternoon.
yeah, you mentioned earlier that this one is, you can do face detection only without the mask, right?
Yes. As of now, we have only that implemented. Yes.
Okay. So basically, this one, face detection, is basically which part of this face is detecting? Is it through eyes or some?
Actually, it is the whole face, not just the eyes, because these Bosch cameras that we're using right now is actually incapable of scanning using the iris. So we can't have iris recognition technology at the moment. So overall, it just detects the whole face.
Okay, thank you.
Judges, do you have any other questions? You have a second question for him?
Yeah, maybe one more for me.
Sure.
Yeah, so my impression is that you are basically, the technique that you use is mostly about RGB camera, real image camera. And I'm not the expert, but when I refer to what we do in car, in automotive, also handphone, mostly for the facial recognition, we are using infrared camera, and sometimes for checking whether humans is there or not, we can use this kind of thermal camera imaging. Yeah, so different kind of techniques are available. Yeah. So my question is that for your team, are you only focusing on RGB type of camera, or you are also looking onto different types?
As of now, we only have the visuals only. I do not think that we have implemented any type of camera that is infrared technology capable. So I would say that because the types of camera that we were given, they may not be capable of having the infrared recognition technology. So it only does so just through the videos alone. Yeah.
Okay.
So I have questions for you. Does your camera work under low light, or let's say in the evening?
Yes, there is actually a low light mode for the Bosch cameras that we are using. Actually, it varies based on the model that we have. So different models, they have different capabilities. Like, for example, like what one of the judges mentioned earlier about the infrared, like all the features, they actually vary based on the model of the camera.
I see. Okay.
I have one more question. The example that we've given is a museum. Can you give me a few other examples where where this can be applied, because museum, like they have to submit the pictures before they enter. Is there other commercial entity that need this application?
Yes, currently in development right now, we have the camera to monitor the car park. So what we have is just one camera to monitor all the lots instead of many sensors on every lot. So we can just put one camera like very high up in the building to just overlook the whole camera. And then what I do, the camera, it just uploads data to the cloud, and then it can display data from the cloud onto a dashboard. So that's it.
So now we know that when I park my car, there will be a camera looking at my car. Thank you, Team 1. And thank you, judges, for your valuable feedbacks and comments. Now we move on to the second project. The second project is titled Air Duct Cleaning Robots. The student presenters are Ong Chen Xiang and S. Navin. Over to you for the video, please.
When you do air duct cleaning, there's a need for manual labor, and there's a lot of various size of pipes that needs to be cleaned. That means there needs to be different tools for the various sizes of these pipes. The team actually designed 4 robots. The 4 robots can be subdivided into 2 categories. The first category is the wall press design, while the second category focuses on making the robot as small as possible.
So for the mechanism that solves this problem, we actually use wall press design. So what it does is just opens up the wheels to press against the diameter of the pipe to allow it to climb vertically. The robot also can maneuver through elbows and T-joints using a motor in the center. For the wall press design, right, it actually uses a 2-axis motor in the center, which allows it to yaw and roll. So for the other small design, right, it actually uses a universal joint in the center, controlled by springs. So it's actually a mechanical design. So it's just that when the robot moves to a bend or whatever, the robot just follows through. For a conventional robot, air whip and brush is typically used. For smaller robots, these things doesn't really work that well with it. So we actually came out with a design called air curtain, which uses pressurized air blown out at 45 degrees to push out the dust.
For the electronics aspect, some improvements that we can make is use QFN package components or smaller SMT components to actually further compress the size of the PCBs that are used in the robots currently to make them a lot smaller. With this QFN package, we are able to come up with smaller printed circuit boards. In the industry, the smallest robot that can move through a pipe is 8 cm and it can only do inspection. However, our robot, which can fit a pipe of 10 cm, is able to do cleaning and inspection. So I think our robot was very well received by our industry partners.
We actually felt quite pleased with it. We worked together as a team just to fulfill those criteria set by the company. Given that the set of criteria that we were able to fulfill is actually a great form of encouragement for the whole entire team.
Now I would like to invite the panel of judges to pose their questions to the project team. So we will start with Mr. Bobby Lim again.
Yeah, hi. I really love the project, and I think one thing that is very fascinating is the fact that you can travel like 10 cm and through that, and then you can do cleaning and inspection both at the same time. I think that's something that the industry will probably they find very fascinating about. So one question is, you mentioned that it's able to go much smaller, right? How much smaller can it actually go?
How much smaller can your robot go?
Currently for like industry standard, right, 10 cm is one of the smallest that it can go already. So for the smallest ever created by industry is only 8 cm, but it's only for inspection. So currently my team actually created 10 cm, which is currently the limit that we actually are able to fulfill for cleaning and inspection. Yeah.
Okay, so just now you mentioned that by using the QFN or SMD, right, then you're able to print smaller circuit boards. Then if that's the case, how small can it actually go?
So as of now, I was using the 1606 package components because this is our first time, because from being from a mechanical in nature engineering course, because we are from DMRO, which is mechatronics and robotics engineering, which is more on the mechanical side. So this is the first time we are actually experimenting with PCBs. This is my first time using PCBs in the circuit. So when I use the 1606 package, I realized that I could make it smaller by using the QFN package components. Using the QFN package components, I think I can get about a 20 to 30% reduction in the PCB sizes. And all these PCBs are custom made. So based on, as we further improve our skills on PCB design, and as we source for better smaller QFN packages, I think we will definitely be able to see a 20 to 30% reduction in PCB size, reduction in PCB sizes.
Thank you. Could we have the second question from Mr. Han, please?
If your sponsors were to give you more time, more resources, more equipment, all right, for example, another half a year more, what kind of improvement would you make?
So as for the mechanical side, right, what kind of improvement we can make is actually finding better motors, better materials. So currently the project is actually due to lack of time, we actually couldn't manufacture some of the products. So with longer time, we actually can source out from better quality materials. Then currently for the project, what we did was that, because due to the fact that we only have 3 months to manufacture 4 robots, most of the robots, the material that used wasn't that able to withstand any impact. So with more time, we can actually send products out to manufacture from outside company, so that the product will be slightly stronger and can withstand all the damages.
Right, thank you.
Mr. Law?
Can your robot handle wet surfaces?
Sorry?
Wet, that means, it's wet, the pipelines that are wet with water. I mean, not totally full of water, but it's just wet.
Okay, so our the air ducts that we're working with are for air alone. So they are more on the ventilation and exhaust pipes. So they are mostly for mostly dry in nature. The Ocean Master Engineering, which is the company we are working with, the pipes that they are using are all air ducts, which are for ventilation, and they are isolated from the wet pipes.
What needs to change? Can your robot handle? I mean, what needs to change? How can you change your robot to handle that?
At the moment, we are still trying to make it airtight, because our robot has to go into dusty environments. Dusty environments would mean dust would have possibly chance to enter. So some ways that we have been trying to solve it is by using bellows, and also by actually using a layer of silicone to actually coat over the PCBs that we are using to protect the electronic circuits. As for the motors, they are not IP68 or water and dust resistant. So we might probably source for IP68 water and dust resistant motor, and we can even look into sourcing for a better camera that is water and dust resistant and is also infrared capable to sense in dark pipes.
Mr. Leo? Runadus, sorry.
Yeah, you can call me Leo. It's okay. Yeah, so one question. The robot seems to me it's like a kind of remotely controlled, but I'm just wondering, how is the power supply and data transfer being carried out? Do you have wire or is it wireless?
The control is via a wireless transmitter, and the cameras, we have 2 cameras. One is based on Wi-Fi, while the other has a video signal and ground coming out, so that we can receive the video output.
Wireless.
we have two. One, because you can see we have a few robots, right? One of them is using the Wi-Fi camera, and the other one is using a wired camera. So we have to wire it to a display outside.
Oh, but the power is by battery. You carry battery in robot, is that?
No, it's a 12-volt DC power.
With battery, or is it wired power supply?
Wired.
So how do you send this robot to the pipe if the pipe, I don't know, 20 meter?
Okay. So based on Ocean Master Engineering, the company that we are working with, they suggested that, or they gave us an insight into how they do the air duct cleaning process. And the air duct cleaning process, actually, they do it based of every 10 meters, they will actually cut the pipe so that they can actually get access to put in their cleaning equipment to clean. So based on that, we work on the length of giving them at least about 15 to 20 meters of wire so that they have enough wire and have enough slack to allow our robot to be, so one person has to still guide the wire, and we still have, we still can use, they still have enough space. Yeah.
Okay. So in that case, that means the pipe has to be like disassembled, and then you can put your robot in. It's not like, my impression is that it can still stay as it is, and you send in, it can go all around the piping network. But okay, I understood. Yeah, thanks for explanation.
Okay.
And Mr. Rico?
Yes, good afternoon. So as you mentioned in the explanation, I can see that there is also compressed air as part of the cleaning, right?
Yeah, compressed air is also used part of the cleaning. So as for cleaning tool, right, we actually had two types of cleaning tool. One is air whip and one is air curtain. So as you can see from the video, right, the air curtain is actually used to push out dust from the pipe, and the air whip is used to heat those dust that's sticking onto the air duct. So with the help of these two cleaning equipment, it actually can help to clear off the dust from the pipe. Then for future improvement, right, for this robot, we actually had plans to add in a brush, pneumatic brush, to push the, to clean the air duct. So that's for the future improvement.
Yeah. So compressor, is it the compressor is coming from the outside source, or there is a built-in compressor in the unit?
The compressed air is coming from the outside source, from a compressor outside. There's just control valves inside the robot, which we can remotely control using our controller to on and off the valve, the respective valves. Yeah.
But would you consider also like putting some built-in compressor inside, so we can reduce the, like this is wireless, this is wired, right? So at least you can reduce this like that's only the wire only, power cable only. Then we can do away with the air hose.
Yeah, because in the ship, right, there's a compressed air readily available based on what our industry partner has suggested. They said that alternatively, we can also go with the brush method, which is to clean, because the current robot that the company is using is also using pneumatics to clean the pipe. So we are also trying to use the same power supply used by the company.
Okay.
Thank you, Team 2, and thank you, judges. Let us move on to the third project, which is titled Container Ship Loading Unloading Systems. The student presenters are Nofani Khairu and Nachi Mondiak. Over to you for the video, please.
Cargo operation requires a lot of man hours while containers are loaded and unloaded off the ship. These man hours are used for counting containers manually. We resolved this issue by installing sensors on each cargo hold, which will detect the presence of the container. The presence of the container will then be indicated on the indicator panel by the indicator lights. This will help to minimize the man hours used to count the containers manually.
So we created a prototype that is a scaled down replica of an actual cargo hold. It's a cargo hold with a 3x3 shipping containers, and at one end of the cargo hold there is sensors attached to show if there's containers in place. For example, if there is a container in place, it will show a red light, and if there is a free space, it will be a green light. We came up with the design for the prototype by drawing it out, and we used AutoCAD 3D to give it a more realistic view. And afterwards, we gathered all the materials we needed, such as the sensors, the lights, and the acrylic boards we used in the prototype, as well as the containers. Our prototype is connected to a software which allows us to troubleshoot it in case of any difficulties. When we first got the prototype, we didn't manage to put the sensors in place correctly, and hence one of the lights were not working. We have to troubleshoot it to fix the lights. Other than troubleshooting, the software also allows us to keep track of the containers that go into the cargo hold, as well as see the positions of the containers from a remote location.
In the future, we hope to install a monitor that shows the diagram that mimics the actual storage plan. This will help to minimize the man-hour use on site. The diagram on the monitor will help the operator to view the loading from a central location.
We are really happy with the end results of this project, and we hope to see that our prototypes will be used in actual pods in the future.
Now I would like to invite the panel of judges to pose their questions to the project team. We'll start with Mr. Bobby Lim.
Hi. So I saw that the design, right, it looks very snugly fit. So regarding in that case, when it scales up, right, does it cause like, will there be any slack that you guys have provided in case that, you know, things are not going to be so snugly fit together?
Can you repeat the question again?
Oh yeah, sure. So the thing is, I saw from your video, right, the prototype that you made is quite snugly fit. Like everything has to like nicely together, like snug together. So in that case, when it scales up to an actual container size, right, then I mean even your holding area and all that, everything has to be scaled up as well. Your sensor and all that has to be scaled up as well. So when that happens, then have you catered to any tolerance or any slack for you know for things to in case?
It means that in the real applications, things might not be so accurately positioned. Will your sensor be able to detect properly?
Yeah.
So actually, for now, we are doing the project, right? Our project, we are detecting the cargo containers according to the cargo holds itself. But in terms of future plans, we might do a sense, as in we might install a sensor that can detect containers of different size, or that, like what you say, it might manage to help with the installation of the cargos in cargo holds.
Okay. Okay.
Mr. Han, you have the second question, please.
Yeah, I'd like to know, very simply, what kind of problem do you run into while doing your experiment, and how do you get them fixed?
Can you repeat the question?
What kind of problem did you run into while doing your experiment, and how did you get them fixed?
When we first installed the sensors, the indicator lights weren't working properly, and we have to troubleshoot the program and reinstall the sensor correctly, and it was working all well after that.
How much help did you get from your lecturer, or you did it by yourself?
Our group did it by ourselves, and our lecturer advised us accordingly.
Right, thank you.
Mr. Law?
Yeah, can you tell what is inside the container? I mean, does your system able to tell what is inside the container?
Currently, the prototype we are making doesn't involve with to see what's inside the container. It's just that the prototype that we did is to be able to detect the presence of the container.
And what would you need to add in order to tell what is inside the container? What features you need to add to your system?
We would have to add a system to detect like an X-ray to detect what is inside the containers. Like for example, what they use in the airports now to see what's in our luggage.
Don't you think RFID would work also? RFID tags on the container itself so that it's linked to a backend database.
Sorry, can you repeat?
Maybe I can repeat. RFID tag, if we tag it onto the items inside the container.
On the container itself.
On the container itself, so sorry.
Yeah,
yes.
and then you link it back to the database. Would it work also?
If we install the RFID tags on the container, it will eventually detect the presence of the container itself, but don't really detect what's inside unless there's a RFID tag installed on the item or products inside the container itself. Then
No, I mean because there's a database or record of what is being shipped in the container. So that is the manifest or that is the bill of lading. So when you can capture that container's RFID tag and you link it back to the bill of lading, wouldn't that work?
Basically, in a container, they have to declare what is already inside the container before they load it onto the ship. Right. So if we have the RFID tag down there, you scan the tag, automatically you are able to know what are the items in the container.
Maybe in the future implementation, then we might put the RFID tags and we'll know what's inside to declare as a database of what items inside the container. Yes.
All right, thanks.
Mr. Liu?
I understand the problem was to count and detect the presence of container, but I just cannot imagine the industry partner Singapore is the busiest port in the world, and you mentioned that they count this manually. I just cannot imagine. Is it something that you get from the ground that this is done manually, this detection and counting of containers?
According to the information we were given, it does state that the containers are being counted manually in the cargo hold. And with that, our project aims to lessen the number of manpower on site so that we can get more work done at a faster rate of time.
Okay. Yeah, if you got it clear is all right. Okay, then maybe one more question. There's no detailed information about the sensor that you're using. What kind of sensor is it? Optical, hard switch, or is it acoustic, or combination of things? Can you elaborate more?
For the sensors that we use for the hatch cover, we are using the proximity sensor. And then the sensors for the cargo containers, we are using the infrared sensors.
Okay, yeah, thanks.
Judges, do you have further questions?
No.
Yeah.
Okay. I have a simple question. How does your system improve productivity if it's really implemented at the port or at the ship itself?
Our system allows the cargo containers to be counted quickly, and when the loading and unloading operation is done, lots of the operators have to be on site to make sure it goes well. So our system detects the presence, and when there's a container in the cargo hold, the indicator panel will show a red light, and when it's empty, it will show a green light. So when the cargoes are loaded, it will quickly detect and they can move on quickly. So more work will be done in a quicker rate of time.
Okay. So
Can I have
thank
a
you, Team
question?
3. Thank
Hello.
you, judges.
Hello, sorry.
We have the fourth project, which is titled
Sorry, Mr. MC.
Sustainable Construction Material
Hello, can you hear me?
Using Plastic Waste in Road Pavement.
Hello,
The
I
student
think Rico
presenters
is trying
are
to answer a
Gracious
question.
O Chin
Hello.
Yi, Sumaya binti Muhammad Sharif.
Excuse me?
Over to you for the video, please.
Hello.
So the current issue with our roads in Singapore is that after years of loading from vehicles, it tends to crack, and hence maintenance needs to be done regularly. This causes a problem for road users, and maintenance fee is also high. Another problem is because of the waste issue in Singapore. Semakau landfill can actually fill up waste until 2040, but at the rate of waste generated now, it could run out of space 10 years earlier, which is 2035. Hence, we would like to overcome this issue.
So the alternative that we come up with is that we will be incorporating plastic waste disposed in Semakau landfill to be incorporated into the asphalt mist, which the testing has shown that is 20% more durable than conventional asphalt. This solution will not only help to solve the waste problems in Singapore, but also helps to improve the physical performance of the roads in Singapore.
There's two parts for the testing. There's the physical and chemical part. For the physical part, it is conducted in an industrial lab together with construction firm SPOH21. So we actually tested a few types of plastic. So from the result, we actually see that all of the plastic has better performance in terms of stiffness compared to the control sample. But particularly the LVPE plastic has the best performance, hence it was chosen.
So aside from the physical side of the project, there's also the chemical side of the project that involves 3 experiment methods, which are a selected weathering test, batch leaching test, and then the last one is the chemical analysis. So we conduct these tests to ensure that it's environmentally safe and to ensure that all of the chemical parameters are within the official guidelines set by the government. So from the results that we have compiled, it has shown that LTP has the most chemical parameters that are within the official guidelines.
So what we hope to achieve from this project is for the waste disposed in Semakau landfill to decrease. So one of the challenges that we faced was that because there were 2 sides to this project, the chemical and physical side, it was hard for both of the sides to understand the processes. Due to COVID also, since we cannot meet up, we did video calls regularly to keep each other updated on what we are doing. So we are very happy with the results that we have gotten, and we hope that our product can be laid out in Singapore's road in the future.
Now I would like to invite the panel of judges to pose their questions to the project team. Mr. Lim, we have the first question, please.
So, hi, I really love that project. One thing is, can you explain more about the batch leaching test and the accelerator weathering test? How do you actually perform those kind of tests?
Okay, so for the batch leaching test, so when we first receive the samples from our partnering industry, Samwo, we will first put it into the oven for easier segregation of the particles before putting it into PET bottles and rotated for a duration of 24 hours. This is to simulate the leaching characteristics of the asphalt. As for the accelerator weathering test, we conduct the test to simulate extreme weather conditions so that we will know if our product is applied in real life context, whether it will be within the official guidelines. Yeah.
Okay, so just one more question, so after you have certified that it meets the official guidelines and all that, right? So what happens in the case that your asphalt mix, right? In the case that it fails after a certain lifespan, then it starts to break down. What will you do about it then?
Are you referring to the asphalt that we'll be testing or
No.
product?
So I'm just saying, in the case that your asphalt mix, right, gets laid out in the roads in Singapore, right? And after like 30, 40 years, and then it starts to break down and all that. So what will you start to do by then? Because by then I think plastics can be leaching or something.
It's so far from our results gathered from the physical and chemical aspect, we have concluded that plastic modified asphalt will be 20% more durable. However, as this concept is still relatively new, further testing definitely need to be done to see whether there are negative consequences in the long run. So I can't really give you a definite answer whether what will happen if the asphalt breaks down in 40 or 50 years down the road.
Oh, okay, no worries. Thanks a lot. Really amazing job, guys.
Mr. Han, the second question, please.
Right. I have a question that requires both of you to answer. Right. What is one most interesting thing that you learned while doing this project?
I will start off the question. So, firstly, because our product involves incorporating plastic into the bituminous mixture, we actually found out there's a lot of advantages of plastic, because some of the properties of plastic is that it is waterproof, it is flexible. Hence, when we add plastic into the bituminous mixture, it actually improves the road performance compared to conventional roads.
Okay, so for me, one of the things that I find interesting is on the topic sustainable development. So as I'm from civil engineering, we don't really cover much on green construction. So I'm happy to be able to be involved in this project to learn more about the various ways that we can do to help close Singapore waste loop.
Right, thank you.
Mr. Law?
Yeah, do you add plastics on top of the current aggregate and cement, or there's some you use less aggregate?
Okay. So actually, this testing have been done for the previous year. So they actually use 5% of plastic to replace the bitumen. So the materials include plastic, bitumen, and binder and aggregates. So what our project did was using 10% of plastic as the percentage.
So you use less
sample.
bitumen. So you use less bitumen.
Yes, correct.
Okay. Good. Yeah, that's all. Thanks.
Okay. Mr. Leo?
Yeah. It's not so clear for me how you process the plastic waste all the way to the asphalt mixture. Yeah. So can you elaborate? What do you do from the, I don't know, plastic waste collection from landfill, cleaning, melting, grinding? I mean, can you elaborate on the process until it becomes a mixture?
Okay, so what we plan to do was, actually a lot of people are already aware of the importance of recycling of plastic. So actually, recyclable plastic, people actually recycle plastic, but there is no purpose for the plastic, hence it is just being burned and incinerated to Pulau Semakau landfill. So what our project does is, we take those plastics and process it into plastic pellets, and it will go through some mixing and compaction before it is being laid out.
Okay, yeah, thanks.
Mr. Rico?
Yeah, good afternoon. Okay, so you said in the video that you are using the low density plastic type, right?
Sorry, can you repeat it?
Yeah, you mentioned in the video that you're using the low density plastic type, which is more compatible with this project, right?
Correct. Yes.
Then which type of plastic is that more? I mean, it's not advisable to use with this project.
So far, we tested for LDPE plastic, HDPE, and PP. Performance-wise, from the physical testing, all of the plastic have better performance in terms of properties compared to conventional asphalt. So for the chemical properties,
from the plastic that I've tested, it's all within the official guidelines.
Okay. Okay, thank you.
Any other question from the judges?
One more question, very brief question, because you use the word sustainability by using certain construction material. How do you equate that with long-term profitability financially?
okay, we do not have the estimated cost efficient value is estimated to be 10% more cost effective by using plastic roads. And some of the factors includes due to incorporated plastic roads actually has better durability. Hence, lesser maintenance needs to be done, which means lesser money needs to be forked out. And also, by using more percentage of plastic instead of bitumen, because bitumen costs around $600 to $700 per ton in Singapore, more cost can be saved by using plastic.
Yep, thank you, good answer. Thank you.
I'm just curious, how many times of try and error and testing have your team done before you come up with these final materials?
Because this is a continuation project, so past years has already tested on different percentage. So we tested on the remaining percentages that they haven't tested on, and the results turn out to be great.
The production process, is it going to be very complex compared with the bitumen that we see on the road? Production of this special construction material, is it going to add to the complexity of manufacturing?
Actually, it won't be complex because the equipment used will be the same for making of plastic modified asphalt as that of for conventional plastic asphalt. So it won't be very complicated to implement.
Okay. All right then. Okay, thank you, Team 4. Thank you, judges, for your valuable feedback and comments. The last project of the day is titled AI-enabled solution using field programmable gate array technology. And the student presenters are Chai Yen Lu and Wong Chun Sing, Benjamin. Let's have a look at the video, please.
Nowadays, people usually have their mobile devices and computers for their daily usage. So in each of these devices, there is a central processing unit, or basically the brain of each of these devices. As such, the FPGA board is actually similar in this case, where it is reconfigurable and integrated chip that is used in this board. Comparing computers and FPGA boards are generally better in its performance when comparing the graphics processing unit of the computer. Not only that, the FPGA boards are smaller in size, making it less bulky.
Other than performance and size, power consumption of the FPGA is much lower than the GPUs. Its customizability is also very important, as in our mobile devices, it's not customizable, which makes it harder to send out to the market, as well as its lower cost.
For my team, we have used this technology to create an automatic facial recognition system that can allow students to record their attendance during lessons. Right now, we are using an attendance system that requires lecturers to generate the code. This actually allows students to do everything automatically without the need of a lecturer to generate any code.
So for my team, we are doing an AI-enabled IoT-controlled system to maintain and support the vertical farm. The vertical farm has sensors that can control the water, cooling of the subsystems, as well as the lights. For our project, we also aim to have an AI system where we are able to enhance the security access of the farming field. This farming field will also be maintained and controlled by a control center. So for this vertical farm, we are using FPGA, so it's much faster as compared to this, which is using Raspberry Pi. If we were to expand this vertical farm, it will be troublesome, as each rack will require one Raspberry Pi as compared to one FPGA for multiple racks. So for the future of our project, we plan to grow mushrooms on the top of the rack, as well as trying to put a dripping system for the plants.
What we want to do is to increase the speed of the FPGA board and the performance of the webcam output. Not only that, we want to make the whole product integrated into one single small compact size.
So in the future, Singapore intends to make a 30% ingrown crops using vertical farming. I believe the FPGA can help to enhance this process as it is much faster and more efficient.
Because of the many benefits of the FPGA, we believe that this technology will be widely adopted by many industries in the future.
Now I would like to invite the panel of judges to pose their questions to the project team. Mr. Lim, first question.
So yeah, hi. I really like the project. That's a really good initiative. So more regarding the FPGA board, right? So where else can you see the applications being used for, aside from vertical farming, vertical farms and for classroom system? Where else can you actually apply it to?
Other area or applications other than the farming that you have demonstrated?
Well, for your information, firstly, I like to introduce FPGA. So FPGA is a IC chip that can be reconfigured. Thus, it can be customized for different applications. So just like what you say, it can be utilized for different applications. So besides the vertical farm that Benjamin's team has developed and our face recognition application, it can also be used for many AI solutions, because artificial intelligence is very massive in complexity. So FPGA has the ability to execute functions in parallel. Thus, it's very suitable for any AI solutions that you can think of. For example, for any face detection or land detection that you want to achieve, it's all can be done using FPGA.
Okay, thank you. One other thing is, so how does the cost compare to a Raspberry Pi?
The cost compared to Raspberry Pi, because if you think about large scale type of project, which like you need multiple Raspberry Pis, because for now, for my vertical farm, if you were to do the traditional Raspberry Pi way, we will need one Raspberry Pi per rack. But if you think about it, if you have an FPGA, you can have multiple racks with just one FPGA. Yeah. So I think that FPGA is much more like wide scale in a sense, yeah.
Okay.
And then for our solution, our face recognition attendance tagging system, the cost of our FPGA board is around 250. And then I know that there is a team at 5G Garage in our SP campus. They actually use this JSON Nano board, which costs thousands of dollars to do the same application as ours. So I will say that compared to those other boards that can do the same function, our board is actually cost effective, while it can do things with a higher efficiency.
Okay, thank you.
Mr. Han, can we have the next question, please?
Yes, I understand that the specification of this project comes from the indoor farming, your industrial sponsor. I would like you to describe the changes or the value add that you actually make by yourself to make this project more unique.
Because for my project, it is a progressive project. So it has been, this is our version 5 of our vertical farm.
Yes.
So from the last one, it was Raspberry Pi, now it was FPGA. We're also trying to find out like new ways to grow different plants, because normally it will be the normal fruits such as like strawberries or kailan. But like now we are trying to go for something more exotic, like mushrooms, any other, or we are trying different types of watering, such as mist spraying or using dripping system.
Right, thank you.
Mr. Law?
Yeah, I think programming FPGA is like it's almost like assembly language. How long did y'all take to program the solution?
For our face recognition attendance taking system, the programming is still in progress as we try to further improve our algorithm. So the programming language that we use is actually Python because we found this framework called Leaching, which enable us to program FPGA from a software level. Yeah.
Okay, yeah, that's good. Yeah, good. All right, thanks.
Benjamin, got things to add?
For me, right, is because we got two different types of programming. One of them will be the FPGA and one of them is the dashboard. But for the FPGA part, we spent about a few months just so that we can get everything all connected together. Because we also have a Wi-Fi, which we had a bit of trouble with connecting to the cloud system.
Yeah, I understand the challenge of hardware programming.
Okay, Mr. Liu?
I think you have been promoting the advantage of FPGA compared to other solutions like GPU, Raspberry Pi, etc. I'm just curious, what are the weaknesses of this FPGA compared to others that may limit its implementation in the industry? Can you give us some explanation?
Weaknesses.
Disadvantage of using FPGA.
One of the disadvantage that I can think of is that because we need to program it from a hardware level, so for those software engineer, they really require those knowledge in hardware field to program this board. Unlike other development board like Raspberry Pi, you just need to have the knowledge in Python or C++, those common programming languages. Yeah, so that is one of the challenges that those users of FPGA board will face. Yeah.
But in the industry, what about in industry? Why this is not widely used? Yeah, I mean. Is it performance, reliability, or I'm not sure. I mean, you have been explaining about the development itself. I understood, yeah.
Basically, it's saying is using FPGA less reliable, more problematic compared with the standard controller solutions that we always use?
I believe that FPGA is less problematic in a sense, because I find it to be much more faster because able to execute multiple things all at once. So what I believe is FPGA is like the future we are supposed to head towards to, because for me, I think FPGA is kind of new because when we tried to research online, it was very hard to find videos or information on how are we gonna program this FPGA board. So as compared to a Raspberry Pi, which I think that we should work towards the FPGA. That's what I think so.
Okay, thank you.
Mr. Rico?
Yes, good afternoon. So that indoor farming is very interesting. So this indoor farming, have you compare the products of indoor farming and then the outside conventional farming? I mean the products, let's say vegetables.
Compared to traditional farming, what I receive is it has better, healthier crops as compared to the normal traditional farming. And it's also, it requires less space because instead of building horizontally, we are building like vertically up, which means like there's quite endless possibilities of how much we can like plant, in other words. It also requires less manpower and also less cost in general. And it also helps to go towards Singapore's goal of having a 30% locally grown crops by 2030. So I feel like we are showing like a different alternative on how we are going to tackle this problem for Singapore.
So basically this indoor plant is pure organic, or you're using also some pesticide, insecticide?
We are using nutrients, but I think it's organic though, I think so.
Organic?
Yeah.
Okay, thank you.
I guess you don't need any pesticide because it is indoor. There's no insect flying around, so I think so. Judges, any more other questions for the team, please? FPGA is something that we don't really teach you much on it. What are your challenges that you all face in developing the project itself? Do you have to study very hard from internet or things like that?
Yes, yeah, like what you say, FPGA is actually quite new, and then we couldn't really find much resources online, but we still make use of them as much as we can. And in order to get our hands on this very new technology, we also contact directly with the AVNet engineers to gather any, to receive some guide from them. Yeah.
Okay. Benjamin?
If you're talking about the challenges I faced during the project, because for my team, we split into a dashboard group and a FPGA group. For me, I'm part of the dashboard group. And the problems I have faced is that we are given with a new type of dashboard creator software. It's called Mendix, which is fairly new. It's running on low code, which for me, for us, we find it very hard to find information about it, as well as because it's low code, it's harder to find, to make specific logic for it, in other words, yeah.
Okay. We have come to the end of the live webinar session. A big thank you to the judges for taking the time off from their busy schedules to provide valuable and useful comments for the students. Thank you all to members of the audience for being part of this event. Your presence today showed the students your support for their efforts. For those who want to find out more on the Partners Forum live webinar tomorrow, please refer to SP Open House website for the timing and registrations details. Have a nice day. Thank you.